All right, last in our mini unit on statistics, we're going to be talking about margin of error. So first, I didn't leave a space for it, but at the very top of the page, we're going to go ahead and write down what a margin of error is. So the margin of error is the max expected difference between the population parameter and the sample estimate of that parameter. And remember, the sample estimate of a parameter is called a statistic. So parameters are the numeric values that describe a population. Statistics are the numeric values that describe a sample. So the margin of error is the max expected difference between the number that we find that describes a sample and the number, the corresponding number that would have described the actual population that we are interested in finding information about. So the formula for margin of error is 1 over the square root of n, where n is your sample size. And just a note is that statisticians have a 95%, not a 95, but statisticians have 95% confidence in the range that you get as a result of the margin of error, which means that 95% of the data that you find will fall between that range. So when you get the margin of error, it's going to fall between a range of numbers, and that they have 95% confidence that that the data will fall between that range. And this does not include extremes. All right. So here is an example that 900 American teens were surveyed about their favorite ski category of the 2002 Winter Olympics in Park City, Utah. Ski jumping was the favorite of 20% of those surveyed. So 20% is the statistic of the 900 sample size. Use this result to predict how many of the 31 million American teens, so that would be the population, like all American teens, that favor ski jumping. So what we're going to do is we're going to say 1 over 900, square root of 900. We're going to go ahead and just calculate that real quick. So I'm going to type in 1 over square root of 900. I get 1/30th. I just want that as a decimal. So I get that this is approximately 0.03333, repeating. And so if I take this and move it 2 decimal places to the right, which is how you take a decimal and convert it into a percentage, this would be plus or minus 3%. Plus or minus 3% is our margin of error, our MO, or our margin of error. So the parameter that we expect to have for the population is that 17% to 23% of the 31 million Americans favor ski jumping. Okay, so 20% were surveyed, and we're going to say 20% plus or minus 3% would give you a 17 to 23% range. That was their favorite activity. All right. Side note, in statistics courses, you'll find more accurate ways of finding the margin of error within varying levels of confidence. So 90% confidence intervals, 95, 98, whatever, you'll find it. But this is just kind of the basics of what we look at to find, it's better than nothing as kind of an introduction. All right. So find the margin of error for a survey of 100 American teens. So we're going to say 1 divided by the square root of 100, and we'll see what that is. I'm going to type it in this way so I don't have to keep converting my answer into a decimal. So this is 0.10, and that was not approximately, that was exact. And then I'll go ahead and convert that into a percentage. So I'll move my decimal 2 places to the right, and that gives me 10%, which means that the parameter that I'm expecting here would be 10% to 30% of American teens would have that as their favorite. All right, if we were to find the margin error in the same context, but the survey had 9,000 teens, then you would say 1 over 9,000. And here it's also, or not also, sorry, it's approximately 1%. And here I'll go back and put plus or minus. Plus or minus. And so that would mean that the conclusion that we could make based on the survey was that the population parameter was somewhere between 19 and 21% of the 31 million American teens favored ski jumping. So you could see that as we get more, as our sample size gets bigger, we have a more accurate range within that parameter. So if our survey was 90,000 teens, let's see what we can get here. 1 divided by square root 90,000. Ooh, here, 0.00333333 repeating. So here, if I move this 2 decimal places to the right, I get plus or minus 0.3%. Cookie with sprinkles on it for lunch. Well, not for lunch, but with my lunch. So this means that the parameter would be 19.7% to 20.3%. So the conclusion that we could draw about the margin of error based on the size of the sample is that the larger the sample size, the closer the statistic gets to the parameter. So the larger the sample size, the closer the statistic gets to the parameter. that means the smaller the margin of error gets. Okay. So next it says, if you want to cut the margin of error in half, what would you need to do to your sample size? So what I'm going to do is I'm just going to take any number for a margin of error, and I'm going to just pick an even number, so it's something that I could want to cut in half. So I'm going to say, let's say that we wanted, and you could do this on your paper and just choose any even number that you want, but let's say that we wanted our margin of error, we started off with a margin of error of 18%. So let's say that we say that whatever our sample size was, it gave us a margin of error of 18%. And so we want to cut that in half. Our goal then to cut it in half would be that whatever our new sample size is, we should get a margin of error of 9%, right? So we want to cut that margin of error in half. We want it from 18% to 9%, okay? So now I'm going to say, all right, the math that I would have done here is I would have got 1 over the square root of n equals 0.18. That's what I would have gotten. And so let's go ahead and solve this problem. So I'm going to get rid of the fraction here by multiplying by the square root of n on each side. So I get 1 equals 0.18 times the square root of n. And then I'll divide by 0.18, divide by 0.18. So I get square root n equals 1 divided by 0.18, 5.5 repeating. And then I'll go ahead and square both sides. And so I'm going to go ahead and just take this and square it. So my n would need to be approximately 31 people, 30.86 people, to have a margin of error of 30% and a margin of error of 18%. And a margin of error of 18% is not good. That's pretty far off. So, but we just want to see, so 31 people. Okay. So we just want to see what would need to happen to our sample size. So let's go over here. We're going to do the same thing. So I'm going to have 1 over square root n equals 0.09%. I'm going to multiply by the square root of n, multiply by the square root of n. I get 1 equals 0.09 times the square root of n, divide by 0.09, divide by 0.09. So 1 divided by 0.09 is, so square root of n equals 11.11111 repeating. I'm going to go ahead and square both sides. So I get n is approximately 123 to 124. So that So 124 divided by 31 is 4. So if you wanted to cut the margin of error in half, then you would need to quadruple your sample size. Quadruple your sample size if you want to cut the margin of error in half. So as you can imagine, if you wanted your samples, if you wanted your margin of error to get a lot smaller, you would need a much bigger sample size. And we kind of talked about this the other day, that in one of the videos that the issue always with statistics is that there is a balance there between what is cost efficient and then what can help you get accurate data. So even though we might want to talk to more than 30 people to have something that is more accurate than 18 per, give or take 18%, because 18% is a pretty wide range. 20% of the population of America's teens like this, plus, so it's somewhere between 2 and 38% of America's teens really think this is their favorite because we could only talk to 30 people. But maybe it was really hard to track down 30 people, so it costs time and money and that sort of thing to be able to talk with people depending on the context and the situation, what it is that you're trying to survey. So how large would a sample need to be for a margin of error to be 5%? So here we are solving 1 over square root n equals 5%. So if you want to look back, we can shortcut some of this information. We can see that both times that we were doing this, we have 1 divided by the percent of a decimal equals square root n. So I've got 1 over square root n equals 0.05. Square root n equals 1 over 0.05. And then I'm just going to need to square both sides. So 1 divided by 0.05 squared, 400. How large would the sample size need to be for a margin of error of 2%? We're going to do the same thing. So square root n is going to be 1 divided by 0.02, and then we're going to square both sides. $2,500. Okay, so go ahead and work on the rest of these. Fun.